Okay, so we're moving on to grade 10 work, and we're still going fairly quickly through this. Maybe you're going, oh, it's not quick enough. Maybe you're going, anyway. So we're going through these because you should have seen these ones. So this is going to take us up to angles in same sec. Then the next video will be angles in same sec. So the first one is perpendicular drawn from the center of a chord bisects the chord. So what we've got here is if we are given the center and there's a line that's drawn down here, it's perpendicular. If something's perpendicular, what does that mean? Well, it means that it's at 90 degrees at right angles. So if you've got this at 90 degrees to this is a chord. Remember, chords go from one point in the circumference to the other. Then what that means, that's what we're putting with this arrow here. Then what it means is it bisects. What does it mean to bisect a line? Well, a line segment, I should say. To bisect means to cut in half. So it means that this length here, AM, is equal to MB. So if it's 90 degrees, then they're equal. And your reason then is perp from center to chord. And the second one that looks very similar is the opposite, and that is if you're given a line from the center and that line hits a chord and it hits the middle of it, so you're given that this AM is equal to MB, then what does that mean? Well, it's written here, so I hope you just read it or you remembered it and said, well, what it means is that that's 90 degrees. So the only thing that I think you can get wrong in terms of these, or not the only thing, but one thing that could mix us up is if we mixed up these two reasons. Remember, the reason relates to what you're given. So are you given that it's perpendicular from center to chord, in which case it's equal, or are you given that the line goes from the center to the midpoint, in which case it's perpendicular. So as two quick examples how they might be used, if you're given this from the center and you're given that 90 degrees, well, work through it. Just tell me, write down quickly, what's the essence of this question? How do you work out AB and therefore OC? Well, for AB is just going to be half of that one because that's equal to that. So if the whole thing's 8, then that's going to be 4. Reason? Well, we were given the 90 degrees, so our reason's perp from center to chord. And if we got 3, 4, and a right angle triangle, so just to cut that bit out, right angle 3, 4, probably not the first time you've seen a right angle triangle with side lengths 3 and 4 and 5. And really for this, if you said OC equals 5, as long as you write down the reason Pythagoras, you don't have to show 3 squared plus 4 squared equals x and actually OC squared. Therefore, you don't have to show all those million steps. OC is 5, Pythagoras, it's 3, 4, 5. Basic Pythagorean triple. Okay, and then the same idea here. Just work through very quickly. What would you be doing here when you're given this, and which reason would you use? Okay, so you're given that there's a line going from the center to the midpoint of the chord, so that's going to be your reason, line from center to midpoint of chord. And if this whole thing's 16, then you know that this length's 8. That's just a given. There's no reason needed. But you know that this is 90 degrees. So that's your first OBA. That's right, OBA equals 90 degrees. And from there, Pythagoras, your friend again. Okay, so let's go through. This is the two. Let's keep going through on this video, I think. The angle which an arc of a circle subtends, blah, 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 blah. Basically, if there's an angle at the center, then it's twice the angle at the circumference. And just as kind of a way to do these, I kind of put my fingers on A and B. So this is just a little tidbit of how maybe, and I don't know, I'm interested how your previous teacher, I don't know, how they did it. So let me know, I'll leave a spot for the question after this, is that we've got A and B as our starting point. From A and B, we can kind of create this angle here at the center, but also starting at A and B, we can create, I think subtend is probably the fancy word for it, but what we can do is we can create Where's my purple? I really like that purple. Okay, well, we can also create this angle here at C. So starting at A and B, we can go to the center and we can go to the circumference. So we know angle at center is 2 times angle at circumference, and we can get it that way. So even for this one, starting at A and B, we can create an angle at the center. There it is. And we're starting at A and B, we can also create an angle at the circumference. Hey, do we know any relationship between the angle at the center and the angle at the circumference? Yes, we do. Angle at center is angle 2 times angle at circumference. Okay, and it doesn't matter. So again, starting at A and B, we can create an angle at the center. Also, starting from A and B, we can create an angle at the circumference. So running through these, here's an angle at the center starting from A and B. And also from A and B, we can create an angle at the circumference. So therefore, can I draw? Answer is yes. I'm not going to leave that as a question. I can draw. No, but the angle at the center is 130. So therefore, what's the angle at the circumference? Cool, 65 degrees, because the angle at the center. Okay, so we got it. Angle at the center. Also starting from A and B, we can create another angle. That one's at the circumference. See how we're starting at the same point. I'm really belaboring this point because I find it very useful for circle geometry. Did you see it like that before? Is that how you used it? Pop me some feedback. Okay, so that's that. And the last one is just a very special case. What is the angle at the center? What's the angle of a straight line? Well, it's 180 degrees. So if the angle is that, and from A and B, what do I keep saying? We can create another angle, this one at the circumference. Well, if the angle at the center is 180, and it's twice the angle at the circumference, well, the angle at the circumference must be 90 degrees. But because it's such a special case, gets a special reason, angle in semicircle. And that's where we're going to leave it for now. Until the next video, hope you're doing well. Goodbye.